Hello there, and welcome to the Sleepy Nature Channel. Tonight, let yourself settle into a soft place where your breathing can slow and your thoughts can drift like mist across still water. We're going to explore something gentle and fascinating, lakes that hold secrets in their depths, waters that whisper stories of chemistry and time. These are the acidic lakes of our world, places where nature mixes its own gentle potions beneath the sky. Take a breath. Let your shoulders drop. You're safe here, just listening, just drifting. There are lakes on this earth that glow with colors you might see in dreams: emerald green, turquoise blue, milky white. These aren't ordinary waters. They're touched by the slow breath of volcanoes, by minerals rising from deep beneath the ground, by the patient alchemy of stone and time. One such place rests in the crater of a volcano in Java called Kawah Ijen. The water there shimmers in shades of turquoise, beautiful as a gem held up to morning light. The color comes from sulfur, that ancient element that smells faintly of matches and hot springs. The lake is acidic, its waters holding a pH similar to battery acid, yet it sits there peacefully, reflecting clouds and sky. The acidity doesn't shout or storm. It simply exists, a quiet fact of chemistry, as gentle in its way as the minerals dissolving slowly in a mountain stream. In these waters, bones would indeed dissolve over time, calcium giving way to the patient chemistry of hydrogen ions. But this isn't a story of danger or it's a story of transformation, of how nature recycles everything, turning solid into liquid, returning all things eventually to the earth. Think of it as a very slow kind of alchemy, happening at the pace of stone wearing smooth in a riverbed. Another lake sits in the highlands of Ethiopia, in the Danakil Depression, one of the hottest places on Earth. Lake Afrera rests there, its waters warm and acidic, fed by volcanic springs that bubble up from below. The lake sits beneath a sky so vast it seems to hold all the patience in the world. The water doesn't rush, it simply receives what the earth gives it, day after quiet day. Around these acidic lakes, you won't find the usual reeds and cattails. The plants that grow here are specialists, adapted over countless generations to thrive where others cannot. They've learned to live with the chemistry, to find their way in these unusual waters. Life adapts. Life finds a way, and it does so softly, without fanfare, like moss growing on the north side of a tree. In Yellowstone National Park, there are hot springs and pools so acidic they've been given names like Emerald Pool and Morning Glory Pool. Their colors shift with the minerals dissolved within them, with the microscopic life that floats in their warmth. Blues and greens swirl together like watercolors mixing on paper. These pools steam gently in the cold mountain air, their vapor rising like soft thoughts drifting upward. The acidity comes from sulfuric acid, formed when volcanic gases meet water. But even these harsh-sounding chemicals create beauty: the vivid colors, the clear waters, the strange and lovely landscape around them. Chemistry can be an artist, painting with patience and time. If you're enjoying this gentle journey into nature's quiet chemistry, you might leave a small like on this video, just a soft tap to let me know you're here, drifting along with these waters. In Iceland, there are geothermal areas where acidic waters pool on the surface, warmed by the heat of the earth below. The ground around them steams softly, and minerals paint the rocks in shades of yellow, orange, and white. It looks like a painting done in pastels, all soft edges and gentle hues. The Icelandic word for these places speaks of heat and steam, of the earth breathing. These waters are not still. They bubble very gently, releasing gases that have traveled up from deep within the planet. Carbon dioxide, hydrogen sulfide, sulfur dioxide, each one a messenger from the underworld, telling stories of heat and pressure and slow-moving stone. But on the surface, all you hear is a soft bubbling, like a pot of tea about to brew. The acidity of these lakes isn't constant. It shifts with the seasons, with rainfall, with the activity of the earth beneath. In wet seasons, fresh water dilutes the acids, making the lakes gentler. In dry times, evaporation concentrates the minerals, making the waters stronger. Everything flows, everything changes. Nothing stays exactly the same from one moment to the next. In New Zealand, there are crater lakes perched in the calderas of dormant volcanoes. Lake Rotokawa is one of these, a body of water so acidic that its pH hovers around 2.5, similar to lemon juice. Yet it sits there peacefully, surrounded by green hills and native bush, a pocket of chemistry in a landscape of soil and tree. Birds fly overhead, clouds pass. The lake simply exists, doing what it does. The water in Lake Rotokawa is warm, heated by volcanic activity below. Steam rises from its surface on cold mornings, drifting upward into the air like departing dreams. The warmth and the acidity come from the same source, the slow cooling of ancient magma far beneath your feet. Everything connects. Water to stone, heat to chemistry, sky to earth. If you'd like more stories like this, gentle explorations of nature's quiet wonders, check out our playlist. There are many soft journeys waiting there, each one a place to rest your mind. In the Philippines, on the island of Luzon, there's a crater lake called Taal. It sits within a volcano, which sits on an island, which sits in another lake, nature nesting its wonders one inside another like a gentle puzzle. The crater lake itself has periods of high acidity, fed by volcanic gases rising through cracks in the earth. The local people have lived near this lake for generations, understanding its moods, respecting its chemistry. They know when the waters are safe and when to keep their distance. This is ancient knowledge, passed down through stories and observation, through the slow accumulation of wisdom. We learn from the land when we pay attention. We learn from the water when we watch and listen. The animals around acidic lakes are often specialists too. Certain insects can survive in acidic waters, their bodies adapted to the chemistry. Some bacteria thrive in these conditions, finding energy in the very acidity that would harm others. Life is inventive. Life finds niches in the most unexpected places. In some acidic lakes, the water is so clear you can see deep down, far deeper than in ordinary lakes. The acidity prevents much organic material from accumulating, so there's less sediment, less cloudiness. It's like looking through the cleanest window imaginable, down into depths of turquoise and blue. Clarity comes in unexpected forms, in unexpected places. Take another breath. Feel yourself sinking deeper into comfort, like sinking slowly into warm water, supported and safe. The rocks around acidic lakes often show the effects of the water's chemistry. Limestone dissolves slowly when touched by acidic water, creating smooth surfaces and unusual formations. It's like watching sculpture happen at the pace of seasons, each year wearing away a tiny bit more. The stone doesn't resist. It simply transforms, becoming part of the solution, joining the water in its slow dance. In Japan, There are acidic hot springs called underscore quote underscore zero underscore, where the pH is low enough to tingle the skin. These aren't lakes exactly, but pools where acidic volcanic water collects naturally. The Japanese have bathed in these waters for centuries, finding them soothing despite, or perhaps because of, their unusual chemistry. The minerals in the water are believed to be healing. The warmth certainly is. And the steam that rises carries that warmth up into the cool air, a gift from earth to sky. The smell of sulfur is common around acidic volcanic lakes. It's the scent of hydrogen sulfide, that rotten egg aroma that might seem unpleasant at first. But in these places, it becomes part of the atmosphere, part of the experience. Your nose adjusts, and soon it's just the smell of this particular earth, this particular water. Everything belongs where it is, even the smells we might not expect. In Costa Rica, Poás volcano holds one of the world's most acidic lakes in its crater. The pH has been measured as low as 0, essentially as acidic as battery acid. Yet, the lake sits there quietly, occasionally bubbling, reflecting the gray-green sky above the crater rim. Scientists visit this lake to study it, carefully, respectfully. They collect samples to understand how such extreme chemistry can exist in nature. Knowledge grows slowly, like trees reaching upward toward light. The temperature in these volcanic crater lakes can be surprisingly high, sometimes reaching 40 or 50 degrees Celsius, warm enough that steam continuously rises from the surface. This creates a microclimate around the lake, a zone of warmth and moisture even when the surrounding air is cool. Nature creates its own weather, its own small worlds within larger ones. If you're finding peace in these quiet facts, you might consider leaving a comment below, sharing what brings you comfort or what you'd like to explore next. This channel grows through your gentle participation. Some acidic lakes change color throughout the day as the sun moves across the sky. The minerals in the water reflect light differently at different angles, so the same lake might be pale blue in the morning, deep turquoise at noon, and almost gray-green in the evening. The water is always itself, yet always appearing new. In Antarctica, there are lakes beneath the ice that are believed to be acidic, fed by chemical processes happening in total darkness under immense pressure. These waters have been isolated from the surface for millions of years, yet they persist, quietly existing in their dark world. Even in the most remote places, water finds a way to be. The minerals dissolved in acidic lakes include iron, aluminum, sulfur, and many others. These elements give each lake its unique character, its particular color and chemistry. Iron might add a reddish or orange tint. Sulfur contributes yellows and greens. Aluminum can create milky cloudiness. Each lake is a recipe mixed by the earth itself over centuries. Around some acidic lakes, you'll find deposits of pure sulfur, bright yellow crystals that look almost artificial in their color and clarity. Miners have sometimes collected this sulfur, though always carefully, always with respect for the chemistry of the place. The earth offers gifts, and sometimes those gifts are strange and beautiful. Microorganisms called extremophiles live in acidic lakes, thriving in conditions that would destroy most life. These tiny beings, bacteria and archaea, have evolved special proteins and cell walls that can withstand the acidity. They go about their lives in these extreme waters, eating, reproducing, existing. Life's creativity knows no bounds. even at the microscopic level. Some researchers believe that studying these extremophiles might help us understand how life could exist on other planets, in acidic oceans beneath ice, or in volcanic vents on distant worlds. These tiny creatures in Earth's acidic lakes might be windows into possibilities we've barely imagined. The small teaches us about the vast. The local reveals the universal. Take a moment to breathe deeply. Let your body sink a little further into rest. You're held here, supported, safe. The water in acidic lakes often has a peculiar texture when you touch it. Slippery, almost silky, though of course you wouldn't want to immerse yourself in the most acidic ones. This slipperiness comes from the minerals dissolved in the water, from the way the acids interact with oils on your skin. Water teaches through touch, through sensation, through the language of chemistry written on skin. In Russia, the Valley of Geysers in Kamchatka holds numerous acidic pools and springs. The landscape there looks otherworldly, steam rising from dozens of vents, water bubbling up in various colors, the ground painted in mineral hues. It's like a palette of pastels spread across the earth. Beauty emerges from the most unexpected processes, from heat and pressure and chemical reaction. The rocks around acidic lakes sometimes develop what's called underscore, quote, underscore one underscore, where the surface becomes rough and pitted, almost like the texture of a sponge. This happens as the acid dissolves certain minerals preferentially, leaving others behind. Over time, the rock transforms, its surface becoming a record of years of patient chemistry. Everything that touches the acidic water is changed by it, slowly, gently, inevitably. Birds sometimes visit acidic lakes, landing on the shores to rest during migration. They drink from streams that feed into or out of the lakes, from places where the water has mixed with fresher sources and become gentler. Even in these chemical landscapes, life finds its way, finds the safe places, the drinkable waters. Wisdom is knowing where to land, where to drink, where to rest. Remember, if you enjoy these peaceful explorations, our playlist holds many more stories of forests, of rain, of quiet, natural wonders. Each one is a place to let your mind settle and your thoughts drift. In some acidic lakes, bubbles of gas rise continuously from the bottom, creating patterns on the surface, circles and swirls that expand and disappear, expand and disappear. These gases come from volcanic activity below, from the slow decomposition of minerals, from chemical reactions happening in the deep. The water breathes in its way. The earth breathes. Everything exhales. The indigenous peoples who live near acidic volcanic lakes often have stories about them, tales of spirits, of Earth's power, of respect and caution. These stories carry practical wisdom wrapped in narrative, teaching each generation to understand the land's moods and temperaments. Stories are how we remember what matters, how we pass knowledge gently from hand to hand, from voice to ear. In the Azores, volcanic islands in the middle of the Atlantic, there are crater lakes with varying levels of acidity. Some are gentle enough for swimming, others are strictly for admiring from a distance. They sit in the green landscape like jewels in different settings, each one its own particular chemistry, its own shade of blue or green. Diversity is everywhere in nature, no two waters exactly alike, no two lakes precisely the same. The sound around acidic lakes is often very quiet. There are no fish splashing, no frogs calling in most cases, just the gentle sound of bubbles rising, of steam hissing softly, of wind moving across water. This quietness has its own quality, its own kind of peace. Sometimes the most profound rest comes in these empty spaces, these quiet places. When rain falls on an acidic lake, it dilutes the water very slightly. Fresh water mixes with acidic water, and the chemistry shifts just a little. The lake becomes gentler during rainy seasons, harsher during dry times. It's a rhythm, a cycle, like breathing in and out. Everything pulses, everything responds to the larger patterns of weather and season. Scientists who study acidic lakes often speak of them with a kind of awe. These extreme environments teach us about the limits of life, about chemistry in action, about the Earth's creative power. Each visit to an acidic lake is a chance to witness nature's laboratory, to see processes that have been happening for millions of years. Knowledge grows when we approach the world with curiosity rather than fear, with wonder rather than judgment. You might leave a gentle like if these stories are helping you relax, if they're creating a soft space for your mind to rest. Your small interaction helps others find their way here too. In some acidic lakes, the bottom is covered with a layer of sulfur, bright yellow and fine as powder. This sulfur accumulates over time, settling gently like snow, building up year after year into a soft, strange sediment. Even at the bottom of these unusual waters, there's a kind of beauty, a quiet accumulation of time. The evaporation from acidic lakes can create unique mineral deposits on the shores, crusts and crystals that form as the water level rises and falls with the seasons. These deposits often have delicate structures, like frost patterns or the crystalline arrangements you might see in a geode. The water leaves its signature everywhere it touches, writes its chemistry in mineral script. Let your eyes grow heavy if they want to. Let your breathing slow. You're exactly where you need to be. The light that reflects off acidic lakes has a particular quality, bright, clear, almost sharp. This is because the water is so free of suspended particles, so chemically hostile to the organic matter that usually clouds lakes. The clarity allows light to penetrate deep, to bounce off the bottom, to emerge in brilliant colors. Clarity comes from unexpected sources, sometimes from the very harshness that prevents cloudiness. In the crater of Mount Katmai in Alaska, there is a lake that formed after a massive volcanic eruption in 1912. The lake is acidic, heated by volcanic activity below, and it sits in perfect isolation at the top of the volcano. To reach it, you'd have to climb through volcanic ash and pumice, through a landscape still recovering from that ancient eruption. Some places ask for effort to reach them, and in that effort, we find appreciation. The steam that rises from acidic lakes in winter creates ice formations around the edges, delicate structures where the warm, acidic water meets the freezing air. These ice sculptures are temporary, melting and reforming as temperatures shift, as wind changes direction. Beauty doesn't always need to last forever. Sometimes its value is in its impermanence. Certain algae can survive in moderately acidic waters, creating thin mats of green along the shores where the acidity is diluted slightly by runoff. These algae are pioneers, living on the edge of what's possible, making the most of the narrow margin where chemistry allows life. Life settles where it can, finds the edges, the boundaries, the places where extreme meets tolerable. The minerals dissolved in acidic lakes eventually precipitate out, forming deposits of sulfur, silica, and other compounds. These deposits can build up over thousands of years, creating layers that record the lake's history, its changing chemistry, its response to volcanic activity and climate. Time writes itself in layers, in sediment, in the slow accumulation of mineral and memory. If you'd like to explore more of these gentle nature topics, our playlist is there for you. Stories to help you drift, facts to let your mind wander softly through. In some acidic crater lakes, the water level rises and falls dramatically depending on volcanic activity. When activity increases, more water evaporates and the level drops. When activity decreases, the crater fills again, slowly, patiently. The Earth has its own rhythms, its own reasons for rising and falling. The fish that live in streams feeding into or out of acidic lakes are often hardy species adapted to fluctuating pH levels. They've learned to tolerate changes, to move to better water when conditions shift. They're survivors, quietly going about their lives in challenging environments. Adaptation is a form of wisdom learned over generations, encoded in body and instinct. Around acidic lakes, you sometimes find animals that have adapted to eat the specialized plants and insects that live there. These animals, certain birds, small mammals, have carved out niches in these unusual ecosystems, finding food sources that others can't access. The web of life extends even into the most unlikely places, connecting everything in subtle ways. The salts that form from evaporating acidic water can be incredibly delicate. Thin crusts that crumble at a touch, crystals so fine they look like dust. These formations are fragile, temporary, easily destroyed by rain or wind or the careless step of a visitor. Some beauty requires gentleness from us, requires that we look without touching, appreciate without disturbing. In Ethiopia's Danakil Depression, acidic pools sit among salt flats and volcanic formations, creating a landscape so alien it's been compared to other planets. The pools are various colors, yellow, green, orange, and they steam gently under the intense sun. The Earth is endlessly creative, endlessly willing to surprise us with new combinations of chemistry and landscape. Scientists sometimes place sensors in acidic lakes to monitor their chemistry continuously. These instruments send back data about pH, temperature, dissolved gases, creating a constant stream of information about how the lake breathes, how it changes hour by hour and season by season. We learn by paying attention, by listening carefully to what the Earth is telling us. Feel yourself drifting now, like mist rising from warm water, like steam ascending into cool air. You're light. You're at peace. The bacteria that thrive in acidic lakes often form colored mats, reds, oranges, yellows, adding to the vivid palette of these places. These colors come from pigments the bacteria produce to protect themselves from intense sunlight and from the chemicals in the water. Even the smallest life forms paint the world, add their colors to the landscape. In some acidic lakes, the bottom is marked by depressions where gases bubble up more intensely. These vents create small currents in the water, circular patterns of flow that are visible from above. The water moves, always moves, even in these quiet places. Stillness and movement coexist. The surface may be calm while currents flow beneath. The acidity of these lakes is actually a kind of balance. Acids and bases in the water seek equilibrium, and the lake's pH represents the current state of that chemical negotiation. Add fresh water, and the balance shifts. Add volcanic gases, and it shifts again. Everything seeks balance in chemistry, as in life, finding its level over time. When volcanic activity increases beneath an acidic lake, the water sometimes becomes warmer, more acidic, more active. Bubbles increase, steam rises more vigorously, and the lake enters a more energetic phase. Then, when activity decreases, everything calms again. The lake breathes in and out, fast and slow. Cycles within cycles, rhythms within rhythms. Nature knows how to dance with itself. If these quiet facts are soothing you toward rest, you might share this video with someone else who seeks gentle sleep, who needs a soft place to land at day's end. Some acidic lakes have underwater hot springs where heated acidic water pours in from below. These springs create plumes of warmer water that rise through the cooler layers above, mixing and swirling, adding to the lake's complex internal circulation. Even within one body of water, there are worlds within worlds, layers and temperatures and chemistries all coexisting. The rocks that form the basins of acidic lakes are often volcanic, basalt, andesite, rhyolite, stones born in fire shaped by cooling magma. These rocks are themselves the source of many of the minerals that dissolve into the water, creating its unique chemistry. Everything comes from somewhere. The lake's acidity is the story of the rocks beneath it, told in dissolved minerals. Indigenous guides who lead visitors to acidic lakes often speak of respecting the water, of understanding its power, while not fearing it. They teach visitors where to stand, where to step, how to appreciate the lake without disturbing it or endangering themselves. Wisdom is passed person to person, hand to hand, voice to voice, in quiet lessons that echo through generations. The horizon around a crater lake is often defined by the rim of the crater itself, a circular boundary between lake and sky, water and air. Standing at that rim, you look down into the basin, into the blue or green waters below, and the world narrows to this one perfect circle of chemistry and color. Sometimes the world becomes very simple, very focused, very clear. In winter, some acidic lakes create their own weather. The warm water meets cold air and generates clouds of steam that drift across the surface, obscuring the water, creating a mysterious atmosphere. The lake disappears into its own exhalations, becomes invisible behind its own breath. We all contain mysteries, hidden depths, things that emerge and recede with the seasons. The silence around an acidic lake can feel sacred. Perhaps it's the absence of the usual lake sounds, no lapping of fish, no chorus of frogs. Perhaps it's the knowledge that you're in a place where chemistry rules, where the usual rules of life are suspended. Sacred spaces exist everywhere, even in places defined by pH and mineral content. Breathe slowly now. Let each exhale carry away a little more of the day's concerns. You're safe in this story, safe in this gentle exploration. The study of acidic lakes has taught scientists about how life might exist in extreme environments throughout the universe. If bacteria can thrive in Earth's acidic waters, then perhaps life could exist in the acidic clouds of Venus, or in the chemical lakes of Titan, Saturn's moon. The local teaches us about the cosmic. The earthly prepares us to imagine the alien. Some acidic lakes have names given by early explorers, names that speak of demons or death. names that reflect old fears of these strange waters. But modern visitors often find them beautiful rather than frightening, fascinating rather than forbidding. Names carry old stories, old perspectives. We can honor them while seeing with new eyes. The reflection of sky in an acidic lake is often perfect, mirror-like, because the surface is so still, so free of ripples caused by aquatic life. Clouds appear below as clearly as above, creating the illusion of depth where there's only reflection, of sky continuing downward into water. Sometimes what we see is not what's there, but a beautiful illusion, a trick of light and surface. In Chile, the Altiplano region holds acidic lakes at high altitude, where the air is thin and the sun is intense. These lakes, some green, some white, some blue, dot the landscape like scattered gems, each one a small world of chemistry in the vast expanse of the high desert. Water collects even in the driest places, finding depressions, gathering slowly over centuries. Around some acidic lakes, you'll find deposits of borax and other salts, white crusts that glitter in the sun. These minerals precipitate from the water as it evaporates, leaving behind evidence of what was dissolved within, a reverse archaeology where, instead of digging down to find the past, you see it deposited on the surface. The past rises to meet us sometimes. Instead of waiting to be excavated, consider leaving a comment about what helps you find peace. What natural phenomena speak to your soul? This gentle community grows through sharing. The temperature gradient in a volcanic acidic lake can be quite sharp. Cold water on top, warmer water below, with distinct boundaries between layers. These thermoclines affect how the lake circulates, how heat distributes, how chemistry varies with depth. Layers exist in water, as in life, each one with its own character, its own temperature, and density. Some acidic lakes are fed by rivers that start out neutral or even basic, but become acidic as they pass through volcanic terrain, picking up sulfur and other compounds. By the time they reach the lake, their chemistry has completely transformed. We all change as we journey, picking up influences, transforming through the terrains we cross. The first scientists to study acidic lakes had to be creative, finding ways to measure pH and collect samples without being harmed by the corrosive water. They developed special equipment, used long poles and bottles designed to resist acid, took careful precautions. Knowledge sometimes requires caution, requires respect for the power of what we're studying. In some acidic lakes, seasonal rains cause dramatic changes. The entire lake might shift several pH units in the space of weeks, becoming gentler with dilution, then concentrating again as the dry season returns. The life around the lake adapts to these cycles, waiting out harsh periods, thriving when conditions improve. Patience is built into nature, encoded in the rhythms of rain and drought, acidity and dilution. The minerals dissolved in acidic lakes include some that are quite valuable: sulfur for industry, certain rare earth elements. But harvesting these minerals would disturb the lakes, would destroy their pristine chemistry. So most acidic lakes remain untouched, their minerals undisturbed, their chemistry intact. Some things are more valuable left alone, appreciated rather than extracted, witnessed rather than exploited. Birds migrating overhead sometimes mistake the colored acidic lakes for ordinary water, especially at dawn or dusk when light plays tricks with perception. but instinct usually guides them to safer waters nearby, to the streams and ponds where life thrives, rather than these chemical jewels that only look inviting. Instinct protects, guides, knows things that eyes alone cannot discern. Your breathing is slow now, steady and deep. Your body knows how to rest, knows how to let go. In satellite images, acidic lakes often stand out dramatically, bright blues and greens and whites against the brown and gray of volcanic terrain. From space, they look like eyes staring upward, like gems set in rough stone. Perspective changes everything. From above, from far away, we see patterns we might miss up close. The chemistry of an acidic lake is never static. It's always responding to inputs from below, to rain from above, to evaporation and temperature changes. The lake is less a thing than a process, less a fixed body of water than an ongoing chemical conversation. Everything flows, everything changes, everything responds to forces we may not even see. Some acidic lakes have been studied for decades, with researchers returning year after year to measure, to sample, to understand. These long-term studies reveal patterns, how the lakes respond to volcanic cycles, to climate variation, to the slow changes of geological time. Understanding grows slowly, built up sample by sample, year by year, observation by observation. The local communities near acidic lakes often have mixed relationships with them. Pride in the unique landscape, caution about the dangers stories passed down, about accidents or near misses. These relationships are complex, layered, as nuanced as the chemistry of the lakes themselves. We live with what's powerful by learning it, respecting it, telling stories about it. If you're finding rest in these words, you might explore our playlist, where many more gentle topics await: forests, rain, flowers, the quiet phenomena of the natural world. In some acidic lakes, underground channels connect them to other bodies of water, creating hidden hydrological systems. Water flows in darkness beneath the surface, carrying minerals and heat, linking one lake to another in ways invisible from above. Connections exist beneath the surface, channels and flows we cannot see, but can sometimes infer from careful observation. The sediment cores taken from acidic lakes tell stories going back thousands of years. Layers of volcanic ash from ancient eruptions, shifts in chemistry that correspond to climate changes, the accumulation of minerals year by quiet year. The past is written at the bottom of lakes, in layers so thin you can barely see them, yet so persistent they last millennia. Some acidic lakes have no outlet. They're closed basins where water enters, but leaves only through evaporation. This means that everything that dissolves into the water stays there, accumulating, concentrating, creating ever more complex chemistry. Some systems hold everything within themselves, becoming richer and more complex with time. The bacteria in acidic lakes sometimes produce biofilms, thin layers of living material that coat rocks and sediment. These biofilms are communities, multiple species of bacteria working together, sharing resources, creating microenvironments within the larger harsh environment. Even in extreme conditions, cooperation emerges, community forms, life finds ways to support itself. Around the shores of some acidic lakes, you can find perfectly preserved footprints from decades ago. The acidic mud has hardened around them, protecting them from erosion. Each footprint is a moment frozen in time, a visitor's step preserved in chemistry. We leave marks on the places we visit, impressions that may last longer than we imagine. The sound of wind crossing an acidic lake is the same as wind crossing any water. That soft rushing, that whisper of air moving across liquid. In this, the acidic lake is no different from a mountain stream or an ocean bay. The wind doesn't care about chemistry. It moves across all surfaces with equal grace. Some things transcend chemistry, transcend the particular, speak to the universal nature of water and air and earth. Feel yourself sinking deeper into rest, into the soft embrace of sleep that's waiting for you, patient and kind. The clouds that form above acidic lakes sometimes carry tiny droplets of acidic water lifted by evaporation and wind. These clouds are not dangerous. The acid is too diluted, but they're a reminder that the lake extends beyond its visible borders into the air, into the weather systems above. Everything extends beyond its apparent boundaries, influences what's around it in subtle ways. In Indonesia, the country of many volcanoes, acidic crater lakes are numerous. Each one has its own character, its own chemistry, its own color. Some are tourist destinations, others are remote and rarely visited. Together, they form a chain of chemical jewels across the archipelago. Diversity is the rule in nature, no two alike, each one its own particular expression of chemistry and circumstance. The plants that grow near acidic lakes are often tough, leathery species that can tolerate acidic soil. Their leaves are thick, their roots shallow, spreading wide rather than deep. They've adapted to extract what nutrients they can from challenging soil to survive where others cannot. Adaptation is creativity expressed through biology, through the slow invention of new ways to be. Scientists sometimes compare acidic lakes to primordial Earth, to the conditions that might have existed billions of years ago when life was first emerging. In this view, acidic lakes are windows to the past, places where we can study chemistry similar to what our earliest ancestors encountered. The ancient persists in pockets, in places where unusual conditions preserve what's elsewhere transformed. If these explorations are bringing you peace, a gentle light helps others discover this refuge, this soft place to land at day's end. The wildlife that does live around acidic lakes, certain insects, specialized plants, adapted bacteria, form a simplified ecosystem, one with fewer species but unique interactions. It's like a haiku compared to an epic poem, fewer words, but each one carefully chosen, essential. Sometimes simplicity has its own elegance, its own completeness. In the steam rising from acidic lakes, you can sometimes see rainbows when the sun angle is right. The water droplets in the steam act as prisms, splitting light into its component colors. Beauty emerges from vapor, from the meeting of light and moisture. Beauty finds ways to manifest, even in the steam of acids, even in the harshest places. The deepest acidic lakes can be dozens or even hundreds of meters deep, vertical columns of chemistry with different conditions at different depths. To descend into such a lake would be to pass through layers of temperature and acidity, each layer its own world. Depth contains multiplicity, holds variations we cannot see from the surface. Some acidic lakes are relatively young, formed in eruptions within human memory, within living recollection. Others are ancient, thousands or tens of thousands of years old, patiently dissolving rock and accumulating minerals since before recorded history. Time scales vary wildly in nature, from the instant to the eternal, and everything in between. The monitoring of acidic lakes includes watching for changes that might indicate increasing volcanic activity, rising temperatures, increasing acidity, more vigorous bubbling. These lakes are sentinels, early warning systems for the volcanic processes beneath them. The earth speaks through its waters, tells us what's happening in its depths through chemistry we can measure. Around some acidic lakes, steam vents release gases that whistle and hiss as they escape. These sounds are the voice of the earth, quite literally. Compressed gases finding their way to the surface, expanding into the atmosphere, singing their high-pitched songs. The earth has a voice, speaks in hisses and bubbles in the soft sound of steam escaping. Let your thoughts drift now like steam rising, like mist ascending, lighter and lighter, floating upward into peace. The research conducted at acidic lakes includes astrobiology, the study of potential life elsewhere in the universe. By understanding how life adapts to Earth's acidic waters, scientists develop hypotheses about how life might exist in the acidic oceans of Jupiter's moon Europa or in the methane lakes of Titan. Our curiosity extends from the local to the cosmic, from this lake to distant worlds we may never touch. In some acidic lakes, the chemistry varies dramatically from one end to the other, especially if there are multiple hydrothermal inputs. One part of the lake might be more acidic, another less so. One area hotter, another cooler. The lake contains multitudes within its boundaries. Unity contains diversity. Wholeness contains variation. And both are true at once. The people who work at acidic lake sites, volcanologists, chemists, park rangers, develop a deep appreciation for these places. They speak of them fondly, despite the dangers, despite the harsh conditions. There's something compelling about places where chemistry rules, where nature shows its raw power. We often love what we come to understand, grow attached to what we study deeply. The paths around acidic lakes are often marked carefully, keeping visitors on safe ground, away from unstable shores or areas of high temperature. These paths wind through otherworldly landscapes, offering views that seem to belong to different planets. Safe passage is offered through dangerous terrain, guidance through beauty that could harm. Consider sharing a comment about what you've learned, what surprised you, what brought you comfort in this exploration of acidic waters and patient chemistry. In the laboratory, water from acidic lakes reveals its secrets under analysis. The exact concentrations of various ions, the presence of trace elements, the populations of different bacterial species. Each sample tells a story of where it came from, what it's been exposed to, how it's changed. Science is the art of reading the stories written in chemistry, in biology, in the structure of matter itself. The ice that forms at the edges of acidic lakes in winter is often layered and complex, recording the freeze-thaw cycles, the changes in water chemistry, the influx of fresh snow and rain. To read an ice core from such a lake is to read a calendar of winter, a record of the season's progression. Ice remembers, preserves, holds information in its frozen structure. Some acidic lakes have underwater structures, rocks and outcrops visible through the clear water. These structures are slowly dissolving, changing shape year by year, their contours softening as calcium and other minerals are removed by the acidic water. Everything yields to time and chemistry, softens at the edges, gradually transforms. The educational value of acidic lakes is significant. They're living laboratories where students can see chemistry in action, where concepts from textbooks become visible, tangible, real. A pH of 2 isn't just a number. It's this blue-green water, this steaming crater, this unique landscape. Abstraction becomes concrete when we encounter it in nature, when theory meets actual water and stone. The respect with which researchers approach acidic lakes is evident in their careful methods, their safety protocols, their understanding that these are powerful places. They don't take unnecessary risks, don't disturb what they don't need to, approach their work with humility. Humility is appropriate when facing nature's power, when working with forces larger than ourselves. The color of an acidic lake can change with the weather, brighter under sun, more muted under clouds, almost gray in fog. The lake reflects not just the sky, but also our changing perspective, the shifting light of different times and weathers. We see things differently, depending on the light, depending on our angle of approach, depending on conditions we may not control. Soften your jaw. Relax your hands. Let your whole body sink into the support beneath you, trusting and at peace. The bacteria that live in acidic lakes represent some of the extremes of life on Earth. Organisms that have pushed the boundaries of what's possible, that have found ways to thrive, where the very concept of environment seems hostile to existence. Life is relentless, creative, willing to try new strategies, new chemistries, new ways of being. In some acidic crater lakes, the water level can drop dramatically during dry periods, exposing mineral deposits on the newly revealed shores. These deposits, sulfur, various salts, metal oxides, create temporary landscapes of yellow and white and orange, painted crusts that will be submerged again when rains return. The visible and invisible trade places with the seasons, with waters rising and falling. The study of ancient lake sediments sometimes reveals evidence of past acidic conditions, layers that suggest volcanic activity, periods of acidification, times when chemistry dominated. These ancient acidic lakes are long gone, but their memory persists in rock. The past speaks through stone, through layers, through the patient accumulation of sediment that becomes testament. Some visitors to acidic lakes report feeling a sense of awe, of being in the presence of something fundamental. Perhaps it's the visible chemistry, the sense of witnessing Earth's interior processes. Perhaps it's the beauty of the colors, the strangeness of the landscape. Awe is a gift we receive from nature, from encounters with what's larger or stranger or more powerful than our daily experience. If you'd like more of these peaceful nature stories, our playlist awaits. Gentle explorations to carry you toward rest, toward sleep, toward the soft darkness where dreams begin. The mist that rises from acidic lakes is cleanest in the early morning, when temperature differences are greatest. It rises in columns and sheets, drifting across the water, slowly dissipating as it mixes with the surrounding air. Even harsh chemistry can create gentle beauty, mist and steam and drifting vapor, soft as any morning fog. In mythology and folklore, acidic lakes sometimes appear as dwelling places of spirits or gods, places of power and danger, thresholds between worlds. These stories recognize what chemistry tells us, that these are unusual places, borders between the ordinary and the extreme. Stories carry truths that science confirms, wisdom that precedes measurement. The equipment used to study acidic lakes must be acid-resistant, special plastics, certain metals, coatings that won't dissolve. Even the boats used on acidic lakes require special materials, special care. We must adapt our tools to the environment we're studying. Understanding requires the right tools, the right approach, the willingness to meet nature on its own terms. Some acidic lakes are slowly becoming less acidic as volcanic activity beneath them wanes. Over decades or centuries, they may transition to more neutral waters, supporting different life, different chemistry. Nothing stays the same forever. Everything moves toward new equilibria. Change is the only constant, transformation the only permanent state. The relationship between temperature and acidity in these lakes is complex. Sometimes heat increases acidity by promoting the dissolution of certain gases. Sometimes it decreases it by driving gases out of solution. The chemistry is always dynamic, always balancing multiple factors. Simplicity is rare. Most systems involve multiple interacting variables, multiple competing processes all finding their balance. In the silence around an acidic lake, you might hear your own breathing more clearly than usual, might become aware of your heartbeat, of the small sounds your body makes. The quiet invites attention inward, invites awareness of your own chemistry, your own processes. External quiet can lead to internal awareness, to noticing what's always been there, but usually goes unheard. Breathe. Simply breathe. Let each breath carry you deeper into calm, into the soft space between waking and sleeping. The seasons affect acidic lakes just as they affect all waters. Ice in winter, though acidic lakes often resist freezing due to their chemistry and temperature. Fuller in spring with snowmelt, lower in summer with evaporation, replenished again in autumn rains. The calendar of water continues even in extreme conditions, even where chemistry seems to dominate. Some of the most beautiful photographs of natural landscapes include acidic lakes. Their vivid colors, their dramatic crater settings, their steaming surfaces. These images share the beauty with people who may never visit, who may only know these places through pictures and stories. Beauty can be shared at a distance, can travel from eye to eye, heart to heart, through images and words. The pH scale itself is logarithmic, meaning that a change of 1 unit represents a tenfold change in acidity. A lake with pH 2 is 10 times more acidic than one with pH 3. This mathematical structure reflects how dramatically chemistry can vary, how wide the range of conditions in nature can be. Small numbers can represent large differences. Small changes can mean dramatic shifts in conditions. Researchers sometimes use drones to study acidic lakes, flying cameras over the water to map temperature variations, to photograph changes in color, to observe bubbling patterns. This aerial perspective reveals patterns invisible from the shore, shows the lake as a whole system rather than isolated observations. Height grants perspective, distance reveals patterns, and both help us understand what proximity might obscure. If this gentle journey through chemistry and water has brought you peace, you might let us know with a like, might share what resonates with you in a comment below. The conservation of acidic lakes is a quiet priority for environmental organizations. These unique ecosystems, though harsh, are valuable for research, for education, for the simple fact of their existence. Protecting them means managing access, preventing pollution, maintaining the integrity of their watersheds. Protection doesn't always mean preventing all access. Sometimes it means guiding interaction, shaping how we engage with what's precious. In some acidic lakes, the water is warm enough that standing near the edge, you can feel the heat radiating from the surface. It's like standing near a gentle heater, feeling warmth emanate from chemistry and volcanic processes deep below. Heat, rises, always rises, carrying energy from depth to surface, from earth to air. The silence of an acidic lake is not the silence of absence, but the silence of presence, of chemistry happening, of heat rising, of slow processes unfolding at their own pace. It's a silence full of activity, just activity, too quiet or too slow for human ears to perceive directly. Silence contains more than we initially think, holds processes and presences we must attend to carefully to perceive. Some acidic lakes support unique species found nowhere else on Earth, endemic bacteria, specialized algae, insects adapted to the particular chemistry of one specific lake. These species are treasures, repositories of unique genetic information, solutions to environmental challenges found nowhere else. Uniqueness deserves protection, deserves our recognition and care. The long-term monitoring of acidic lakes sometimes spans decades, with some sites having records going back 50 years or more. These records show how the lakes respond to climate change, to varying volcanic activity, to the slow shifts in environmental conditions. Patience in observation rewards us with understanding, with the ability to see patterns that only emerge over years and decades. When people visit acidic lakes responsibly, staying on marked paths, following guidelines, taking only photographs, they participate in a kind of reverence. They acknowledge that these places are worth preserving, worth experiencing with care rather than carelessness. Our behavior toward nature reflects our values, demonstrates what we cherish and respect. Let your mind wander now, like steam drifting across water, like warmth rising into cool air, dispersing gently, softening into peace. The chemistry of acidic lakes is often used as a teaching tool, helping students understand pH, chemical equilibrium, the behavior of ions in solution. Abstract concepts become concrete when illustrated by actual blue-green water, actual measurements taken from real lakes. Learning deepens when connected to reality, when abstract becomes tangible, when theory meets actual earth and water. In some volcanic regions, there are hierarchies of lakes, some highly acidic near active vents, others less acidic farther away, and finally neutral or even basic lakes at the periphery. This gradient represents a journey through chemistry, a spectrum of conditions in geographic space. Gradients are everywhere in nature, smooth transitions from one extreme to another, ranges rather than binaries. The maintenance of trails and viewing platforms around acidic lakes requires special materials, concrete that resists acid, metals that won't corrode, wood treated to withstand harsh conditions. Even our infrastructure must adapt to the chemistry of these places. We build with respect for the environment, choosing materials that can coexist with what's naturally present. Some acidic lakes have legends attached to them, stories of cursed waters, of spirits in the steam, of transformations and magic. These stories may not be scientifically accurate, but they reflect the human response to unusual phenomena, our tendency to mythologize what we don't fully understand. Myth and science are both ways of approaching mystery, of trying to make sense of what seems strange or powerful. Consider exploring our full playlist. If you're finding comfort here, many gentle topics await, many soft journeys into the natural world's quieter phenomena. The evaporation from acidic lakes adds minerals to the atmosphere, though in tiny, harmless amounts. These minerals eventually settle as dust, contributing to soil chemistry in the surrounding area, extending the lake's influence beyond its visible borders. Influence radiates outward, affects what surrounds it, even when the mechanism is invisible or subtle. In the coldest regions, acidic lakes can have ice floating on their surface even in summer, chunks of ice that persist because the water below is still cold, still close to freezing despite volcanic heat at depth. These ice rafts drift slowly, melting at the edges, reforming at night. Opposites coexist, ice and volcanic heat, freezing and warmth, all in the same system. The organisms in acidic lakes have become subjects of biotechnology research. Their enzymes, which function in extreme conditions, might have industrial applications. Their survival strategies might inform the design of new materials or processes. Nature is a teacher, an engineer, a library of solutions to problems we're still learning to ask. When volcanic activity beneath an acidic lake decreases, the lake may slowly transform over centuries, becoming less acidic, supporting more life, eventually resembling any ordinary mountain lake. This transformation is another kind of succession, a chemical and biological progression toward something less extreme. Extremes tend toward moderation over time, though the journey may take longer than human life scales. The smell of sulfur that characterizes many acidic lakes is actually a safety feature. It warns animals and humans that the chemistry here is unusual. That caution is warranted. Nature's warning system, written in scent rather than sight. Senses evolved to protect us, to inform us of risks and opportunities, to help us navigate the world safely. The water in an acidic lake weighs the same as any water, has the same essential properties, but its chemistry makes it feel different, makes it behave differently in subtle ways. It's familiar and strange at once, water and yet not quite the water we're used to. Familiar things in unfamiliar contexts reveal new aspects, teach us to see beyond our assumptions. Rest now. Let your breathing deepen. You're held safely in this moment, supported by the earth beneath you, surrounded by the soft air of night. The volcanic rocks around acidic lakes often show beautiful colors. Reds from iron oxides, yellows from sulfur, blacks from basalt. These colors tell the story of the rock's formation, of the minerals it contains, of the processes that shaped it. Color is information. Pattern is data. Beauty is truth made visible to the eye. Some acidic lakes are so remote that visiting them requires days of hiking through volcanic terrain. These journeys are pilgrimages of a sort, undertaken by scientists and adventurers who value the experience of these unusual places enough to invest significant effort. What's difficult to reach often feels more valuable once attained, though its intrinsic worth doesn't change with our effort. The study of acidic lakes contributes to our understanding of global geochemical cycles, how elements move through Earth systems, how chemistry connects atmosphere to hydrosphere to lithosphere. Each lake is a node in a vast network of chemical exchange. Everything connects to everything else, at scales we may not perceive directly, but can trace through careful study. In some acidic lakes, the clarity is so perfect that objects on the bottom appear closer than they are, distorted by the refraction of light through the pure water. This optical effect can be disorienting, making depth difficult to judge. Appearances can deceive, even when clarity is perfect, even when nothing is hidden. If these stories are helping you drift toward sleep, you might consider sharing this channel with someone who needs gentle rest, who seeks soft places to land at day's end. The energy balance of an acidic lake includes heat from below, volcanic, heat from above, sun, and heat loss through evaporation and radiation. These factors constantly shift, creating a dynamic thermal system. Energy flows, always flows, seeking equilibrium but never quite finding it because conditions constantly change. Some acidic lakes are within national parks or protected areas, making them accessible to visitors who want to witness these natural phenomena. These protections ensure that future generations will be able to experience the same wonder, the same unique chemistry and color. Protection is an act of generosity toward the future, toward people we'll never meet who will nonetheless benefit from our care. The bacteria in acidic lakes include species that produce acids themselves, species that neutralize acids, species that ignore acids entirely in their internal chemistry. Together, they form a chemical ecosystem, a community defined by chemistry rather than by traditional ecological relationships. Community can form around any shared reality, any common challenge or resource. When new volcanic vents open in or near an acidic lake, the chemistry can shift dramatically in days or weeks. The lake responds to its geological substrate, to the Earth's activity below, changing its character as conditions beneath it change. Responsiveness is built into these systems, flexibility encoded in their chemistry, change accepted as fundamental. The light at different times of day transforms acidic lakes, golden at sunrise, brilliant at noon, soft at sunset. The same water appears different under different illumination, reminding us that what we see depends partly on how we're seeing. Context shapes perception. Conditions affect observation. And this is true in all seeing. The minerals precipitated from acidic lakes can form deposits thick enough to mine, though most acidic lakes are protected from such exploitation. The minerals accumulated over millennia represent stored value, stored time, stored chemistry. Value takes many forms, some measurable in economics, some measurable only in beauty or scientific interest. Soften everything now. Release tension from shoulders, from jaw, from places you didn't know you were holding tight. Let go, let go, let go. The relationship between acidic lakes and their watersheds is intimate. Every stream feeding the lake, every rain falling on nearby slopes, every mineral weathered from surrounding rocks, all contribute to the lake's chemistry. The lake is not isolated, but connected to everything around it. Isolation is mostly illusion. Connections exist even when invisible, even when unexpected. In photographs taken from the International Space Station, some acidic lakes are visible as bright spots against darker terrain. From that distance, they're just pixels of color, yet they represent all the complexity we've explored. Chemistry, life, heat, time. Distance compresses detail, height simplifies, yet the complexity remains real even when invisible. The preservation of water samples from acidic lakes allows researchers to study changes over time, to compare current chemistry with past conditions, to track trends in acidity, temperature, and mineral content. Memory preserved in labeled bottles, time captured in liquid, allowing comparison and analysis. Some acidic lakes freeze partially in winter, with ice forming at the edges while the center remains open due to rising heat. This creates a ring of ice surrounding open water, a visual representation of the tension between cold air above and volcanic heat below. Systems often show their internal contradictions visually, making invisible forces apparent through their effects. If you'd like to continue this gentle exploration, our playlist has many more quiet journeys through nature's peaceful phenomena. Forests, rain, mountains, all approached with the same soft perspective. The bubbles rising through acidic lake water sometimes create patterns, lines of bubbles from particular vents, circles where bubbles spread outward, areas of vigorous bubbling versus areas of calm. These patterns map the hidden geography of the lake bottom, the locations of gas vents and hot springs. Patterns reveal what's hidden, make the invisible visible through their regularity and variation. The wildlife that successfully lives near acidic lakes, certain insects, specialized birds, have often evolved unique adaptations. Some insects have larvae that can tolerate acidic water, allowing them to exploit resources other species cannot access. Every niche, no matter how extreme, becomes home to something if given enough evolutionary time. The measurement of pH in acidic lakes requires careful technique. The probes must be acid-resistant. The calibration must be precise. The samples must be handled carefully to avoid contamination or changes in chemistry. Precision in measurement honors the reality we're trying to understand, shows respect for accuracy and truth. Some acidic lakes have featured in films and documentaries, their otherworldly appearance making them perfect settings for scenes meant to evoke alien planets or primordial Earth. Their visual drama translates well to screen, capturing viewers' attention and wonder. Beauty is versatile, serves many purposes, speaks to us through multiple media and contexts. The indigenous knowledge about acidic lakes includes not just warnings about danger, but also nuanced understanding of seasonal variations, safe approaches, and the lake's places in larger ecological and hydrological systems. Deep knowledge comes from sustained attention, from generations of careful observation, from respect for what's being studied. The future of acidic lakes depends on volcanic activity continuing, on watersheds remaining undisturbed, on climate staying within parameters that allow these systems to persist. They're vulnerable to changes we may not fully predict or control. Vulnerability is universal. Everything depends on conditions beyond its control. Everything exists in a web of dependencies. Close your eyes if you haven't already. Feel the darkness as a soft blanket, as a gentle embrace, as the natural state toward which you're drifting. The final thoughts about acidic lakes return us to simplicity. They're water with unusual chemistry, beautiful in their way, teaching us about extremes and adaptation, about chemistry and action, about the Earth's creative power. Complexity can be summarized simply without losing truth, can be held gently in mind without needing to grasp every detail. The silence around an acidic lake at night is profound. No frogs singing, no fish jumping, just the soft sounds of steam and bubbling, of water being water despite its unusual chemistry. Night brings its own peace, its own kind of quiet, regardless of chemistry or acidity or pH. The stars reflected in an acidic lake shine just as steadily as stars reflected anywhere. Light doesn't care about acidity, passes through these waters as readily as through pure mountain springs. Some things transcend all conditions, remain constant across all variations of chemistry and circumstance. The wind crossing an acidic lake carries no acid in amounts that matter, just the usual sense of water and earth, of minerals and air, of the world breathing as it always does. The atmosphere around us is always gentle, always breathable, always sufficient for life, even near places where chemistry is extreme. Thank you for joining this quiet exploration. Thank you for letting these facts and images wash over you like gentle waves, like mist rising from warm water, like steam ascending into cool night air. Your breathing is slow now, steady and deep, carrying you toward rest, toward sleep, toward the soft darkness where your body can restore itself, where your mind can finally let go of the day's concerns. These acidic lakes will continue their patient chemistry through the night, through the seasons, through the years. They'll bubble and steam and slowly transform rock into dissolved minerals, as they've done for thousands of years and will do for thousands more. And you can rest now, knowing that nature continues its work without your attention, without your awareness, that the world goes on in its patient way while you drift into dreams. Let yourself float now, weightless and warm, like steam rising from water, like mist ascending into peace. Sleep well, rest deeply. Tomorrow will arrive in its own time, and you'll be ready for it. But for now, just drift, just rest, just breathe. Everything is exactly as it should be. You are safe, you are held, you are at peace. The morning light touching an acidic lake creates reflections that dance and shimmer, even though the water itself is still. The minerals suspended in the water catch the light in particular ways, scattering it, bending it, creating an inner glow that seems to come from the lake itself rather than from the sun above. Light and chemistry collaborate, creating beauty neither could make alone. In some acidic lakes, morning fog settles on the surface, thick and white, obscuring everything. Then, as the sun rises higher, the fog lifts slowly, revealing the colored water beneath like a curtain rising on a stage. This daily transformation happens whether anyone watches or not, a performance for its own sake. Nature's beauty exists independent of observation, continues regardless of witnesses. The temperature of the air around an acidic lake varies dramatically from night to day. At night, heat radiates away, and the air grows cold, even while the lake itself stays warm. At dawn, the contrast is greatest, cold air meeting warm water, creating the conditions for fog and mist. Contrasts create conditions for transformation, for phase changes, for the visible manifestation of temperature differences. Some researchers spend weeks at a time near acidic lakes, camping in the volcanic landscapes, making daily measurements, collecting samples at different times and under different conditions. They develop relationships with these places, come to know them intimately, to recognize subtle changes. Intimacy comes from sustained attention, from returning again and again, from patient observation over time. If you're still awake, still listening, still here with these quiet facts, know that there's no rush. Sleep comes when it comes, and until then, these gentle words will keep you company. The chemistry of an acidic lake can be expressed in equations, reactions showing how sulfur dioxide becomes sulfuric acid, how calcium carbonate dissolves in acidic water. But equations, precise as they are, can't capture the blue-green shimmer, the rising steam, the sense of standing before something ancient and powerful. Numbers and formulas tell one kind of truth. Experience tells another. Both are real, both are valuable. In some acidic lakes, there are areas where the water is slightly less acidic, where a spring of fresher water enters, creating a gradient. Life concentrates in these slightly gentler zones, making the most of the marginally more favorable conditions. Life finds the edges, the boundaries, the places where extreme meets tolerable, and clusters there. The rocks that line acidic lake shores are often smoothed by the water's chemistry, their roughness gradually dissolved, their surfaces becoming polished and rounded. This is erosion through chemistry rather than abrasion, dissolution rather than wear. Time works through many mechanisms, wearing away stone through patience and chemical persistence. Around some acidic lakes, you can find crystals that have precipitated from the water, perfect geometric forms created by the slow organization of dissolved minerals as they transition from liquid to solid. These crystals catch the light, scatter it, create small moments of brilliance in the volcanic landscape. Order emerges from disorder, structure from solution, beauty from chemistry, following its inherent patterns. The sound of rain falling on an acidic lake is the same as rain falling on any water. That soft pattering, that gentle percussion, that sound of sky meeting surface. In this moment, the lake is just water receiving rain, participating in the planet's hydrological cycle like any other lake. Some experiences are universal, transcending the particular chemistry or unusual conditions of any specific place. Birds flying over acidic lakes navigate by landmarks just like birds over ordinary lakes, noting the position of the crater rim, the color of the water, the surrounding terrain. To them, the lake is a visual marker, a geographical feature, regardless of its chemistry. Different beings notice different aspects of the same reality, each paying attention to what matters for their purposes. Breathe with the rhythm of rain falling, of steam rising, of water moving through its endless cycle. Evaporation, condensation, precipitation, and back again. The deepest parts of acidic lakes are often the coldest, despite volcanic heat sources. The warm water rises, leaving the depths relatively cool, creating layers of temperature that shift throughout the day and night. Heat rises, always rises, leaving coolness below, creating structure within what appears uniform from above. In winter, when snow falls on the landscape around acidic lakes, the contrast becomes stark. White snow against dark volcanic rock, cold air against warm water, the seasonal against the perpetual. The lake continues its chemistry regardless of season, regardless of what the weather does. Some processes are independent of seasons, continue at their own pace, regardless of the calendar. The people who live in volcanic regions with acidic lakes often have a particular relationship with their landscape. Pride mixed with caution, familiarity mixed with respect. They know the signs of changing volcanic activity, know when to pay attention, when to take precautions. Living with power teaches its own wisdom, its own way of balancing appreciation with appropriate caution. Some acidic lakes are pilgrimage sites, places people visit seeking something beyond the scientific interest, seeking beauty, seeking the experience of witnessing something unusual, seeking the feeling of standing before nature's more extreme expressions. We seek experiences that move us, that remind us of perspectives beyond the everyday, that shift something in our understanding or feeling. Remember, if these gentle explorations bring you peace, you might share this quiet space with others who seek rest, who need soft landings at the end of their days. The afternoon light on an acidic lake can be intense, especially at high altitudes where the air is thin and the sun is strong. The colored water seems to glow from within. The steam creates halos and light effects, and everything takes on a quality of heightened reality. Certain lights transform what they touch, make the ordinary seem extraordinary, reveal beauty that's always present but not always visible. The fish that live in streams near acidic lakes, in the neutral waters upstream or downstream, are sometimes studied for comparison with fish from ordinary streams. The differences, if any, tell researchers about adaptation, about the effects of environmental stress on populations over generations. Comparison teaches, contrast illuminates. Differences reveal what's essential versus what's flexible. In the spaces between bubbles rising through acidic water, there's stillness. The water between disturbances is calm, clear, patient. This reminds us that activity and stillness coexist, that motion happens within a context of relative calm. Stillness holds space for movement, provides the context that makes change visible and meaningful. The chemistry of an acidic lake at sunset is the same as at sunrise, yet somehow the evening light makes it appear different. Softer perhaps, warmer in tone, as if the water itself is settling toward night's rest. The same reality appears different under different lights, reminding us that perception is always conditional, always contextual. Some visitors to acidic lakes sit quietly for long periods, just watching the steam rise, watching the light change, watching the water's surface respond to wind. This contemplative approach to nature requires no equipment, no measurement, just presence and attention. Sometimes the deepest understanding comes not from analysis, but from sustained, quiet attention, from being with something without needing to categorize or measure it. The minerals dissolved in acidic lakes represent rock broken down to its components, stone transformed into solution, solid become liquid through the patient work of water and chemistry. All transformations involve something being taken apart, something being dissolved or broken down before it can become something new. Rest deeper now. Let these words become less distinct. Let their meaning blur into soft sound. Let sound become simple presence. And let presence carry you into sleep. The night sounds around. An acidic lake are minimal but present. The soft hiss of escaping gases, the occasional pop of a bubble breaking the surface, the wind moving across water. These sounds continue in darkness, the lake's processes unaffected by the absence of light. Chemistry doesn't pause for darkness, doesn't wait for daylight, continues its patient work at all hours. Some acidic lakes have observatories or viewing platforms built nearby, places where people can safely watch the lake over time, can witness changes in bubbling activity, can photograph the changing colors of sunrise and sunset reflected in chemical waters. We build structures to safely facilitate observation, to allow appreciation without interference, to witness without disturbing. The soil around acidic lakes is often poor in nutrients, acidic itself from the lake's influence. Yet certain plants thrive there, specialists that have adapted not just to the acidity, but to the specific mineral composition, to the particular challenges of that specific place. Specialization allows life to inhabit niches others cannot, to thrive where generalists would struggle. In dreams, acidic lakes might appear as magical pools, as sources of transformation, as boundaries between worlds. Our unconscious minds respond to their unusual nature, their vivid colors, their sense of being places where ordinary rules don't fully apply. The strange and beautiful in waking life becomes the symbolic and meaningful in dreams, carrying significance beyond the merely chemical or physical. If you're enjoying these peaceful explorations of nature's quiet wonders, our playlist offers many more gentle journeys through forests and rain, through mountains and meadows, all approached with the same soft attention. The morning after a storm, an acidic lake might show evidence of the weather, debris at the waterline, fresh water diluting the edges, a temporary change in color as chemistry adjusts to the influx. Then over days, the lake returns to its baseline, chemistry reasserting itself. Systems seek their equilibrium, return to their characteristic state after disturbances, restore themselves through their inherent processes. The knowledge gathered from studying acidic lakes contributes to many fields: geochemistry, microbiology, astrobiology, volcanology. Each field takes what it needs, applies the lessons, contributes back new questions and observations. Knowledge is interconnected. Insights from one domain inform understanding in others. Everything connects in webs of understanding. Some acidic lakes are photographed so often they become iconic, recognizable images that represent volcanic landscapes, extreme environments, the variety of Earth's waters. These images travel far beyond the lakes themselves, carrying their beauty to people who may never see them directly. Images allow experience to be shared, beauty to be distributed, wonder to reach across distances that bodies cannot cross. The patience required to study acidic lakes, returning season after season, year after year, taking measurements that reveal patterns only over decades, mirrors the patience of the lakes themselves, their slow chemistry, their gradual transformations. Patient observation honors patient processes, matches its rhythm to the rhythm of what it studies. At midnight, an acidic lake continues doing exactly what it does at noon, dissolving minerals, releasing gases, maintaining its chemistry. Through the balance of inputs and outputs, the darkness doesn't change its nature, doesn't alter its fundamental processes. Consistency is its own truth, persistence its own testament, continuation its own form of being. The stars above an acidic lake shine with light that left its source years or centuries ago, traveling through space to arrive at this moment, to reflect in these unusual waters, to complete a journey that began in fusion and ends in reflection. Everything arrives from somewhere, carries history in its nature, brings its past into the present moment. Let yourself be like starlight reflected, traveling from far away, arriving here, settling gently on the surface of this moment, this breath, this soft descent into rest and renewal. Sleep now, deeply and peacefully, held by the same earth that holds these lakes, supported by the same planet that creates such chemistry and beauty, safe in the knowledge that nature continues its patient work while you rest. All is well, all is quiet, all is peace. Good night.